Hello again, everybody, and welcome to Exercise 2. We are looking at page 141 in the workbook. And here's another exercise involving the divergence of a vector field. Let's read this together. We're going to work through part A. So the divergence of f is x squared plus 2y plus 2z, where f represents the flow of a vector field in cubic meters per second. You might remember that that was kind of a common unit for flux that you talked about back in chapter 19. And what they'd like us to do is to estimate the flux out of a small sphere. They're giving us a specific radius of 0.1 centered at each of the following points. Okay, now one thing I want to make sure you're aware of before we get farther into this problem, notice that they're not giving us a formula for the vector field itself. What they are giving us is a formula for the divergence of the vector field, just for the divergence. Okay, so with that in mind, let's see if we can do part A here. So we'd like to measure the flux out of a small sphere centered at the point 111. How would we do that? Well, let's see. Here it's helpful to remember the relationship between the divergence and the flux. In particular, it's approximately the divergence times volume. Why was that again? Okay, well, let's think about what the divergence was. It was measuring flux per unit volume, flow per unit volume. And so if we multiply that by delta V, which is a volume, the units cancel, and we get the flux that we're looking for. Okay, so if we can do that calculation, we've got an answer to part A here. All right, so first thing we need to calculate is the divergence that we have here. We've got a formula for that, so we'll just go up to the top of the page and substitute our three numbers in. So the divergence is 1 squared plus 2 times 1 plus 2 times 1. And then we're going to multiply it by the volume. Remember that this is a sphere of radius 0.1, so if we use the formula for the volume of a sphere, we're going to get 4/3 pi r cubed, okay, which is going to look like that. Now it's a matter of just crunching out the numbers here. So our divergence works out to be 5. We're going to multiply that by 4/3 pi times 0.1 cubed. Okay, and you can double check my arithmetic here. That turns out to be about 0.021. Okay, what would the units on that answer be? Okay, well, notice what we're calculating is flux, and they gave us units of cubic meters per second in this problem. So that's what our final unit should be here. Okay, and you can try this out with parts B and C. They're going to look very much the same as what we just did.